All right, next we have find the exact value, and I listed a lot of problems here to make sure we're kind of covering all our bases. So, if you're in on level, you're on your answer sheet, you're going to have an entire unit circle blank, which you could fill in. So then you wouldn't necessarily have to draw these little circles, you could kind of point, but you still kind of have to understand how to do it. All right, so sine of pi over 6 is our first problem. So I just draw a real little circle, and I remember that pi over 6 is located in the first quadrant, kind of like where 30 degrees is, and you go over a lot, up a little, so it's square root of 3 over 2, 1/2. And I remember that sine is associated with the y-coordinate, so it's just 1/2. You might say, but Mrs. Puckett, I remember it's y over r. Well, on the unit circle, r is 1, so you don't really have, when you divide something by 1, you just get it itself anyway. So 1/2 divided by 1 is just 1/2. So we could just leave it like that. Cosine of 2 pi, first thing you do is you figure out where it's located. 2 pi is located right here. The coordinate there is 1, 0, and cosine is x, and so the answer would just be 1. Cosine of 150, I draw my circle. 150 is located in the second quadrant, just 30 degrees north of 180, and the coordinate there is negative square root of 3 over 2 and up 1/2. So cosine is the x coordinate, so it's negative square root of 3 over 2. Cosine of 3 pi over 4, if you count by pi over 4s, that's when you cut the middle of the quadrants. It goes pi over 4, 2 pi over 4, 3 pi over 4, voila. And all the middle of the quadrants are square root of 2 over 2. So this would be negative square root of 2 over 2, square root of 2 over 2. Cosine is the x coordinate, so it'll be negative square root of 2 over 2. Next one says, what's the sine of negative pi? Try to trick us by counting negative. All the negative means is that you're traveling in a clockwise rotation. So it would be negative pi, oddly enough it's the same place as positive pi, and it's right there, and so the coordinate there is negative 1, 0, and sine is the y coordinate, so it's just 0. Alright, next I have cotangent of 0. So where is 0? First of all, no matter what, you have to find the angle. This looks like 0 radians because there's no degree symbol, but it's the same place as 0 degrees, it's right here. And the coordinate there is 1, 0. If you recall from our definitions, cotangent is x over y. And so x over y would make this 1 over 0, because that's x and that's y. If you divide by 0, that means it is undefined. So I just write that down. All right, next, going to go up here. This side kind of looks harder. Tangent of pi over 4. So I go, well, pi over 4 lives smack in the middle of the first quadrant. It's square root of 2 over 2, square root of 2 over 2. Tangent by definition is y over x. So the y coordinate is square root of 2 over 2, and the x coordinate is square root of 2 over 2. When you divide two things that are exactly the same, it's like they cancel out, and so the answer is 1. Easy, huh? So if you're right in the middle of any of the quadrants, it's either 1 or negative 1. Cool, huh? All right, well, this is a trickster. Sine of 17 pi over 3, I don't even know where that is. So this is how I figured out. What they did is they just went around the circle extra times, okay? So I need to figure it out so it's some multiple of 3, like pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, or 5 pi over 3. I don't really like 17 pi over 3. I don't know where it is. So what I'm going to do is I'm going to subtract multiples of 2 pi, okay? 2 pi is one complete rotation. So if you subtract 2 pi, let's just over here remember that 2 pi, if you wanted to have a denominator of 3, which you have to do when you're subtracting fractions, common denominator, you'd multiply top and bottom by 3. So 2 pi is actually 6 pi over 3. Because 6 over 3 reduces to be 2, right? Okay, so I'm going to subtract 6 pi over 3. And what does that give me? 17 pi minus 6 pi gives me 11 pi over 3. Okay, I still don't know what that is. So I have to subtract 6 pi over 3 again. So 11 pi minus 6 pi is 5 pi over 3. Yahoo, Mountain Dew, I know where 5 pi over 3 is. 5 pi over 3 is down here, right here. The coordinate there is you go over 1/2, down square root of 3 over 2. Sine is the y coordinate, so my answer is negative square root of 3 over 2. Just as an explanation, now that we're looking at the circle, how did they get 17 pi over 3? They went 6 pi over 3, that's one rotation, 12 pi over 3, and then 12, 13, 14, 15, 16, and then 17 right here. I forgot to count this one. So each rotation is 6 pi over 3. So to get it back down, I just subtract multiples of 2 pi. All I'm doing, 6 pi over 3 is 2 pi, but I just need to subtract something with a common denominator. So I subtracted it once, it was too big, I subtracted it again, and then I got what I needed, okay? So 5 pi over 3 is there. I know what that location is. Sine is y, so that's why we chose negative square root of 3 over 2. All right, cotangent. Remember, cotangent is x over y, and at 30 degrees, the coordinate there is square root of 3 over 2, 1/2. So it's x over y, so that would be x, which is square root of 3 over 2, divided by y, which is 1/2. Then you just remember your little rhyme. Dividing fractions, easy as pie, flip the bottom and multiply. I think when they teach that in elementary, they might say flip the second. But in pre-cal and in calculus, usually you're handling like a complex fraction like this. So divide the bottom, flip the bottom and multiply. So how does it go again? Dividing fractions, easy as pie, flip the bottom and multiply. So notice I wrote this down exactly the way it is, but the 1/2 I flipped it upside down, and now I'm just going to multiply. But before I multiply, you can cross cancel. So this cancels. So this is just square root of 3. And that is our answer, square root of 3. All right, secant of pi over 3. I remember secant is a reciprocal of cosine, and it's r over x. So then I go, where is pi over 3? Pi over 3 is up here, and the coordinate is you go over 1/2 and up square root of 3 over 2. There's two ways to approach secant and cosecant. You could say it's r over x, so I could say 1 over 1/2, or you could say figure out what cosine is and then just flip cosine upside down. What's the cosine of pi over 3? Had they asked me the cosine of pi over 3, the answer would just be 1/2, right? How come I chose cosine? Because that's a reciprocal of secant. I always think that secant almost looks like cosine written backwards if it was just soc. Except for it's sec. But whatever, that's how I remember. Or s's go with c, c's go with s's. Okay, so what's the reciprocal of 1 over 2? 2 over 1, which is just 2, and that's the answer. If I'd have done the r over x, I would have said 1 divided by 1/2. Dividing fractions, easy as pie, flip the bottom and multiply. So that's how you get 2. Last problem, cosecant of 150. Cosecant is r over y, and it's a reciprocal of sine. So 150 degrees lives over in the second quadrant, 30 degrees north of 180, and the coordinate there is negative square root of 3 over 2 and 1/2. So what's the sine of 150? Sine of 150 would just be 1/2, so the cosecant will be that reciprocal, which is also 2. Yahoo! All right, I think we're done.